Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether my screen is visible or not, right?
Yes, clear.
Okay, thank you. So the last class just I was discussing like Hadoop is providing two services for storage and for processing. For storage, it doesn't use any database. It is going with a kind of file system called HDFS, and for processing, it is using like MapReduce, right? So there are two types of application. Hadoop is meant for batch applications, right? User non-interactive applications where user interference is not required, right? Hadoop cluster group of CPUs or nodes connected in a network. So we got master node and slave nodes. Drawbacks of databases that what we have seen, right? A limited storage, no parallel processing. If volume increasing, speed decreases. Complexity increases, right? Speed decreases, right? Databases can only handle only structured data, right? Okay. Hadoop advantages: unlimited data storage, very high speed processing, can handle all varieties of data. Why databases like Oracle can support unlimited storage? Why not the other things, right? Yesterday we have discussed, right? So all the databases and specialized databases, they have got a limit on the number of slaves or nodes, right? So up to this extent, beyond that, they cannot, right? They cannot support data further. So Hadoop is prevent storage point of view and processing point of view also, right? Storage point of view. When Yahoo first time implemented Hadoop, it went with 4,000 slaves. Currently, it's going with 12,000 slaves, right? Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, going with 42,000 slaves, right? Yes. Yahoo, when first time implemented, Yahoo, when first time, yeah, so processing point of view, for Yahoo has taken a table of 100 TB consisting of 1024 columns, right? Sorting based on 16 columns. The speed of the various databases, right? Like Oracle has taken 3.5 days, MySQL has taken 6 days, Teradata has taken 4.5 hours, Netezza has taken 3 hours, right? And Hadoop has just taken minutes of time, 3.4 or 1. Latest version has taken only 1.2 minutes. That is what the speed of Hadoop, right? Yes. Hadoop ecosystem components, right? Hadoop ecosystem components. HDFS. So Hadoop ecosystem components, right? We have got components for storage and for processing, right? HDFS is meant for storage, MapReduce is for processing, Apache Hive is also a processing. We use like Pig Latin language, and Apache Hive, it is also meant for processing. Here we use HQL, which is similar to SQL. We use like Scoop for import or export operation. Data ingestion tool, right? NoSQL, NoSQL, right? For schemaless behavior, random access, right? HBase, right? Is one of the NoSQL. Yarn, yet another resource negotiator, right? Zookeeper controls and coordinates all the Hadoop components. Flume Kafka for advanced streaming and messaging, and also like Spark, very high speed processing, where we are going to discuss in brief on Spark. Like before going with Spark, like discussing in brief discussion on SCALA, Spark core programming, Spark SQL, and Spark streaming, right? Okay, that's what we are going to discuss as part of this course. And today, just I'm going to discuss how exactly data storage and data processing is happening within the Hadoop, right? How exactly data stored and processed within Hadoop. How exactly data stored and processed. Okay, fine. In Hadoop, data is stored within the file set. Data is stored within the files. Each file is again divided into fixed size blocks. Default block size in Hadoop. Default, what is that? Each file is again subdivided into blocks, fixed size blocks. Default block size is 64 MB, right? It is 128 MB from Hadoop 2 version onwards, right? From Hadoop 2 version. So in Hadoop, data is stored within the files. Each file is again divided into fixed size blocks and distributed across the slaves. Okay. If I observe this diagram, right, just observe this. F1.txt. Assume the size is like 200 MB. The size is like 200 MB. Assume the size of the file is 200 MB. Into number of blocks, into how many blocks it is divided, number of blocks. File size by default block size. Default block size, right? File size by default block size. 200 MB by default block size is 64 MB, right? 200 by 64. 4 blocks. B1 64 MB, B2 block, B3 block, and B4 block. 64, right? This, what is that? 60, 60, 60, 180, 192, and this is only 8 MB. Talk by is only 8 MB, right? Remaining everything it is free, right? Remaining everything it is free. Only 8 MB talk price. Think that f1.txt is a banking data. You got some banking data in this. This f1.txt is data. You got some banking data. And there is one more file, f2.txt, right? f2.txt. There is one more file. The size of this file, assume the size of this file is like 192 MB, right? Number of blocks equal to like file size by default block size. File size is like 192 MB, default block size is like 64 MB if you have like exactly like 3 blocks. Exactly like 3 blocks means like B5, B6 and B7. B5, B6, B7, right? 64 MB, 64 MB and 64 MB, right? All these 3 blocks are occupying 64, 64 and 64, right? See, I said in Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. F1.txt, F2.txt, but each file will be divided into multiple blocks, fixed size blocks. 200 MB divided into how many blocks in this way? 64 MB, 64, 64 and 8 MB. This B1 stored in slave 1, B2 stored in slave 2, B3 stored in slave 3, B4 stored in slave 4. It is stored in slave 5, stored in slave 6, stored in slave 7 and processed parallelly. So this data is going to get distributed across multiple slaves and are processed parallelly. The entire, this is f1.txt, this entire file is not going to get stored in a single slave. If Hadoop data is stored in a single slave, then multiprocessing won't happen. If you got GBs of file, right? The GBs of file, if is stored in a single slave, then no parallel processing going to happen. So what happens? The file, GBs of file or TBs of file, whatever it is divided into multiple blocks, fixed size blocks we say, right? The blocks are distributed across the slaves and are processed parallel, right? Okay, any file in Hadoop divided into blocks, into smaller parts. I can say it into different parts, smaller parts, fixed size. Here, why this here 56 MB is free, right? 56 MB is free, right? Why this B5 data not stored in this B4? Why B5 data is not stored in this B4, right? Why B5 data is not stored in B4? Assume I want to retrieving f1.txt. Retrieving f1.txt means like combining B1 block plus B2 block plus B3 block plus B4 block. If B5 data stored in, if B5 stored in B4, right? +64 +64 plus B4 only 8 plus 56. Think that f2.txt is some telecom data. The data is some telecom data. Right? So totally, if you're combining f1.txt, you are getting 256 MB. But actual file size is 200 MB. So whenever you are retrieving, whenever you are banking data, right? You are getting some part of telecom data, right? 56 MB of other files data, which is a wrong computation, right? So that's why every file is going to have dedicated number of blocks. in a block of a file, the other block data is not going to get stored, right? So here we cannot store B5 in B4. If it is stored, then while retrieving this f1.txt, you are going to get that B2, that is what file to data also into it, right? So every file should have dedicated number of blocks. So here I'm writing that steps, right? Design principles. Design principles with respect to HDFS blocks, which is respect to HDFS blocks, right? Every file, what is that? Every file have dedicated number of, every file should have dedicated number of blocks. In a single block, no two files data, no two files data to be stored, right? To be stored. All the blocks have what? Equal volume. All the blocks have equal volume. All the blocks have what? Equal volume, except the last block. All the blocks have what? Equal volume except the last block. I was just saying that all the blocks have what? Fixed size block 64, 64, 64, except the last block, right? Okay. Okay. Configuring, see here by default the block size is 64 MB. Configuring the block size. See here, configuring the block size, right? Configuring means increasing or decreasing the block size. We can increase or decrease the block size, right? Configuring increase or decrease the block size. By default it is 64 MB, but we can increase or decrease the block size. Okay, so go to the Hadoop install directory, go to the Hadoop install directory. Hadoop folder, the Hadoop folder, right? Within that etc folder, like conf folder, so hdfs-site dot go to the Hadoop install directory, Hadoop etc conf hdfs-site.xml. By default, the block size, the file in Hadoop divided into 64 or 128, right? But even we can increase or decrease the block size. Okay. So in a file, if you got like a big file, right? A big file like a GBs or TBs, right? Only the last block, except the last block, remaining all the blocks will have equal volume, right? It doesn't mean when you got huge storage, right? That a small, that's like minute, like 56 MB is not a huge wastage, right? Hadoop, go to the Hadoop install directory, Hadoop etc conf hdfs-fnside.xml. Open this XML file. Open this. And configure the following. And configure the following, right? and configure the following. So like configuration, just we'll write our user defined tags thread in XML configuration, opening and closing, first opening and closing tag slash configuration. Just by default it will be empty. This hdfs-site.xml file will be empty. Okay, configuration property, name dfs.blocks.size. And the value, right? What value you want for this value? Like I want like 100 MB or 70 MB or whatever I want. Like by default is 64 MB, right? Just let me like 75 MB I'm keeping, right? 75 M slash property. Okay, this is what this thing we need to set, right? The small configuration, that property name is this, and like 75 or 100 or how much you want, you can just set it, right? But okay. Now I'm going to discuss, right, how the data and processing within the Hadoop, data and processing happens within the Hadoop, right? Now I'm going to discuss 4 cases, right? Now I'm going to discuss 4 cases now. Observe 3 cases, sorry. How exactly data storage and processing going to happen within this, right? Fine. Case 1, if the number of blocks is equal to number of slaves, right? If the number of blocks equal to number of slaves, then high speed. Then you see high speed, high parallelism. So number of blocks equal to number of slaves, we get high speed and high parallelism, right? Think that if you have got like 4 blocks equal to number of slaves equal to 4, right? Blocks B1, B2, B3, B4. Number of slaves S1, S2, S3, S4. 4 slaves, right? You see high speed and high parallelism, right? So here I got a file f1.txt file, right? Size. So okay, some 220 MB. Into how many blocks? Number of blocks. The file is divided into blocks, 220 by 64 default block size, right? Total the file size by default block size, you will see like 4 blocks. B1, B2, B3, B4, right? You'll see like B1, B2, B3, B4. How they are going to get stored across the slaves, multiple slaves, right? This is the master and these are the slaves. Think that I got 4 slaves, 1, 2, 3, 4. S1, S2, S3, S4. Yes, B1 stored here, B2 stored here, B3 and B4. B1, B2, B3, B4. So here B1, think that there are some 10 lakh records stored in this. B2 10 lakh records, B3 some 10 lakh records, B4 some 10 lakh records, right? Fine. Here we call this as like name node. It stores some metadata information. It stores what? Metadata, data about data. So the file f1.txt, right, divided into how many blocks, right? B1, B2, B3, B4, right? Where B1 stored in S1, B2 in S2, B3 in S3, B4 in slave 4, right? So in Hadoop, data divided into blocks. If take any file, that file divided into blocks, blocks are getting distributed across the multiple slaves, right? Okay, this is how data storage happens, right? So I have taken a small file and I showed you that in a bigger file, the number of blocks will be more. The slaves data, the blocks will be distributed across the multiple slaves. And data processing, right? Data processing. So here, like your job is to process f1.txt, right? So if I want to process it, should be divided into tasks. In Hadoop, the job always gets divided into tasks. Number of tasks. In Hadoop, always the number of tasks always depends on number of unique blocks. Number of unique blocks, right? And how many blocks? Number of unique blocks means 4 blocks. 4 blocks means how many tasks? 4 tasks. T1 task, T2, T3, and T4. T1, T2, T3, and T4. Okay, 4 tasks. Job is to process f1.txt divided into 4 tasks, right? T1, T2, T3, and T4. T1, T2, T3, T4. T1 for executing B1 block, T1 for executing the B1 block, T2 for executing this B2 block, T3 for executing this B3, yes, T4 for executing this B4, right? So B1 executing this B1 10 lakh records is nothing but a T1 task. B2 10 lakh records, nothing but T2. B3 10 lakh records, B4 10 lakh. So who should execute this T1 task? Who should execute this T1 task among the 4 slaves, right? Which slave should execute this T1? Yes. So you can just unmute yourself and just give your responses, or you can just give a response through short panel, right? I want the sessions to be interactive, right? Whether your answers are correct or wrong, not a problem, but please try to give your response. So here, who should execute this T1 task?
Slave 1.
Slave 1 only, right? There is no other possibility because the B1 block is present in S1. So S1 only should execute this T1 task. Let's take that. Next, who should execute this T2? S2 only. There is no other choice. T3, S3, T4, S4. So this 4 tasks, T1 for executing this B1 block, T2 for executing this B2, T3 for B3, T4 for B4. 4 tasks are executed parallelly by the 4 slaves. 4 tasks are executed parallelly by 4 slaves. Okay, so here all the 4 tasks, all the 4 tasks. All the 4 tasks. are executed parallelly. All the 4 tasks are executed parallelly by 4 slaves. S1, S2, S3, S4. Here, none of the task is in the waiting state, right? All the tasks are executed parallelly by 4 tasks executed by 4 slaves. So, full parallelism, right? Full parallelism, right? No, none of the task is in the waiting state. Yes, the execution code will reside within the slave node only. Yes. Okay. Understood, right? Here, how exactly the data getting stored, divided into blocks. Blocks are distributed across the slaves. And later, how the processing is going to happen. So this is what case 1. If the blocks number of blocks equal to number of slaves, so how many blocks? Those many tasks. Those tasks are executed parallelly by multiple slaves parallelly. Okay, now see, observe this case 2. Number of blocks greater than number of slaves. Four blocks. Assume we have got 4 blocks, only 2 slaves, right? Like you have got blocks like B1, B2, B3, B4. Slaves, only 2 slaves, S1 and S2. 4 blocks, only 2 slaves, S1 and S2. Like less speed. Number of blocks greater than number of slaves, yes. Less speed, right? Okay. So I got f1.txt, think that the file size like 220 MB. Into how many blocks the file gets divided? File size by default block size, like 4 blocks. B1, B2, B3, B4. How these blocks are going to get stored across the slaves? Slave 1, 2, 3, and 4. Sorry. So here only 2 slaves, right? 2 slaves. S1, S2. Only 2 slaves, but multiple blocks. This is the name node, right? Stores the metadata information. That is data about data. Right here, B1 stored here, B2 here, B3 here, B4 here, right? The blocks are going to get distributed across the slaves. F1.txt divided into 4 blocks, B1, B2, B3, and B4. How, where this B1 stored in a slave 1, B2 in S2, B3 in S1, B4 in S2, right? B4 in S2. Fine. Now observe this. This is data, how data getting stored, right? Data processing. Processing this f1.txt, job always divides into tasks. Number of tasks. Number of tasks always depends on number of unique blocks. Number of unique blocks, right? So, and why I'm saying the unique, I'll come to in the coming examples. Unique blocks. Number of unique blocks, how many? 4 blocks. Means 4 tasks. T1, T2, T3, T4, right? Okay. Job is to process f1.txt divided into 4 tasks. Your job divided into 4 tasks, right? T1, T2, T3, and T4. T1, T2, T3, T4. T1 for executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4, right? B1, B2, B3, B4, right? T1 for executing B1, B2, B3, and B4, right? Okay. Who should execute this T1 task? Who should execute this T1 task, right? Who should execute this T1 task? Means that is B1 block executing this B1, right? So this B1 stored in S1, B3 also in S1, B2, B4 in S2, slave 2. So that T1 task is for executing B1 block. Slave 1 only need to execute, right? There is no other chance. T2 task by S2. T3 task is for executing B3 block. S1 only should execute. T4 also by S2. If you observe here, slave 1, slave 2. Slave 1 executing 2 tasks. T1 and T3. Slave 2 also executing 2 tasks. T2 and T4. So when T1 executing here, right? T1 is executing here. T3 will be in the waiting state. T3 will be in the waiting state. Here T2 is executing, right? T4 will be in the waiting state. Means only 2 tasks will be executing at a time. The other 2 will be in the waiting state. So if S1 is busy executing other tasks, assume that there is a query, right? Okay. If S1 is busy in processing other, so who will process the block B1 means there is no other choice, right? B1 is present in S1, so slave 1 only should execute, right? That will be in the waiting state. Here T3 also, B3 is present in T3 task. Compulsory S1 only should execute it. Once the execution finished, when both T1, T2 execution completed, next they will execute T3 and T4, right? Here only 2 tasks are executed parallelly. The other tasks are in the waiting state. That's why here less speed. So if the slaves are less, if the blocks are more, you'll see like less speed, right? Some tasks are in the waiting state. Now observe this task 3. Case 3. More blocks, only one slave. More blocks, but only one slave, right? Think that I got like 4 blocks. 4 blocks is it, right? Only one slave. B1, B2, B3, B4. Only one slave S1. Think that like f1.txt, like of size 220 MB, into how many blocks? File always divides into blocks. 220 by 64, like 4 blocks, right? Divides into 4 blocks, B1, B2, B3, and B4. B1, B2, B3, and B4. The blocks are distributed across this slave. But only one slave we have said, right? We have got only one slave. It's fine. So no other choice. All the blocks stored here itself. B1, B2, B3, B4. All that blocks got stored in the single slave. There is no parallel processing going to happen here in this case. This is the name node. Stores the metadata information, data about this data. Okay, f1.txt into how many blocks? B1, B2, B3, B4. B1 in S1, B2 in S2. Sorry, B1 also, B2 also in S1, B3 also in S1, B4 also in S1. B1 in S1, B2 in S1, B3 in S1, B4 also in S1, right? All are into S1. All these blocks are stored within this S1 only, right? Okay. So data processing. Job is to like processing f1.txt into how many blocks? Number of tasks always in Hadoop, number of tasks always depends on number of unique blocks. How many blocks? Like 4. It's like 4 tasks. T1, T2, T3, T4. Processing this f1.txt, it is divided into 4 tasks, like T1, T2, T3, and T4. T1 for executing a B1 block, T2 for executing B2 block, T3 for executing B3, T4 for executing B4. Who should execute a T1 task? S1 only. T2 task? S1. T3? S1. T4? S1, right? Means all the 4 tasks, T1, T2, T3, T4 are executed by, all the 4 tasks are executed by single slave S1, sequentially, not parallelly, sequentially, one after the another, right? There is no parallel processing. All the one, just like there are 4 tasks, only one person. The one person only should execute all the 4 tasks, means you should execute one after the other, right? Here, if I take a labor example, right, here no parallel processing. If more slaves, more speed. Less slaves, less speed. If only one slave, no parallel processing, right? Assume that here I got 4 tasks. 4 persons are there, right? 4 tasks means like T1, T2, T3, T4. Assume that T1 takes 1 hour, T2 takes 1 hour, T3 takes 1 hour, T4 takes 1 hour. If there are 4 persons executing this 4 tasks, what is the total time taken for executing all this entire job? For executing the entire job, only 1 hour, right? If full parallelism. But if 4 tasks, only two persons. Person 1, person 2. Person 1 should execute two tasks. T1, T2, he should execute two tasks. T3, T4. So here person 1 takes 2 hours to execute this. He also takes 2 hours to execute. Totally time taken is 2 hours. So here very less time, here some more time. If 4 tasks, only one person. So P1 should execute all 1, 2, 3, 4. T1, T2, T3, T4. Totally takes 4 hours, right? So in the same way here also, if the number of slaves are more speed, less slaves, less speed, only one slave, no parallel processing at all, right? If you go back to this case one, right, the first case, observe this first case, right? 4 tasks are executed parallelly by the 4 slaves. 4 tasks are executed parallelly by the 4 slaves, right? Yes, the query was asked. Okay. For T1, T2, T3, T4 means it depends. The task always depends on the blocks, right? Task, how many B1 block? Nothing but T1 task. For executing this B1, T1 task. Executing this B2 records, right? Nothing but T2 task. Executing this B3, nothing but T3, right? Whatever. So here, when 4 tasks are executed parallelly by 4 slaves, right? As here only we have taken a small file size. Think that if bigger file size, multiple tasks by multiple slaves, but suddenly as these are machines, right? These slaves, these are machines. When multiple tasks executed by multiple slaves, but if suddenly if any slave goes down, right? Then two things we can observe here. Two things, two drawbacks you can see here, right? One is the 10 lakh records, the data is lost if the slave is down and the T2 task is failed. When the T2 task is failed, the entire job also failed, right? So here, when multiple tasks are executed by multiple slaves parallelly as they are machines, suddenly if any slave goes down, then the data is lost and the task is failed, means the job is failed. Means how Hadoop is able to overcome this kind of things, right? How Hadoop is able to, because if 10 lakh records lost, think that if it is sensitive data like banking data, right? Huge loss, right? So how to overcome this means Hadoop is coming with a concept called replication and fault tolerance. It's coming with the concept of replication and fault tolerance, right? Okay, what is that replication and fault tolerance? I'll be briefing you in the tomorrow session how these two things are rectified in this Hadoop.
Now, I have one question here.
Yes.
Yeah, so if, for example, if we have only one slave and we are processing, 4 blocks. So you said like one task it will be doing in parallel, and then after first task it will be doing second task and so on. Can't it like one machine only can't execute the 4 tasks in parallel? If we have only one slave and we have 4 tasks, so single machine also, can parallelly execute those all 4 tasks. Is it possible?
See, 1 second. Here, generally, why I'm saying what is the main advantage of this is if the data is distributed, if multiple systems, if you've got multiple slaves, right? If data is distributed across multiple slaves, right? Then only parallel processing happening, right? So here, if you see in the databases, the database table storing in only one system, right? So only that the same system need to store it, the same system need to process it. So here we are making the data to be distributed across multiple slaves, and we are making that distributed data to be processed by multiple slaves, right? So you are going to see high speed parallel processing is going to happen, right? So if in a single slave, just I was saying, right, only one slave need to process the entire data. For example, if you think like GBs of data or TBs of data, like only one system processing it, right? Takes a lot of time. So here data distributing is happening and the data processed by multiple slaves, right? Fine. Yes, like Sriram, right? Sriram, if you want, you can attend. Sriram, there is a other batch going at 6 p.m. Hadoop batch is going at 6 p.m. Just recently, 1 week before this, it was started, right? If you want, you can attend that session, right?
Hello, I'm
Yes, sir.
Sriram. So
Yes, yes.
from when would the 6 p.m. batch would be there, sir? 6 p.m. or 7 p.m.? Anything, sir?
Yeah, 6 p.m. to 7 p.m., right? There is a batch going at 6 p.m. or 7 p.m. Okay. So once you get registered, right, you can just attend whenever a new topic or new component going, right? You can just attend from there, right? Meanwhile, you can just on the basic of videos you can follow from here, right?
Okay,
The
sir.
basics up to HDFS, right? Up to HDFS, the first component for the next 4 5 days, 3 4 days. If you follow here, later you can see anyone once you attend up to HDFS, the first storage component, right? Later any component, right? That's fine. There onwards you can attend from 6 p.m., right? If you can
Is there
attend
any batch from 7 p.m., sir?
there is no batch at 7 p.m. as of now. Only like at 6 p.m. it's going on.
Okay, sir. So once after we register only, we would get the details about 6 p.m. batch, right?
Yeah, 6 p.m. you can get registered. You can just attend that. One you can attend 5 p.m. or 6 p.m. Anything is fine.
Okay, okay, sir. Okay, thank you.
You can attend any of the batches, right? Even in the coming days, if any other batch starts also, you can attend that batch also. If any 7 p.m. batch starts also, that also you can attend if you are missing, right?
Okay, sir. Because I'm comfortable from 6 p.m. only, sir. Because I'm having some work. That's it.
Yeah, yeah. So yes, you can attend any of the batch in the coming days also. Any of the batch. If any new batch starts at 7 o'clock also, you can. Once you get registered, you can attend any of the batches.
Okay, okay, sir.
Yes, there is a question query asked by Sabir, right? Yes, what Spark for processing in which scenario like Hive, which scenario Hive is going to play a role in data processing? Yes, yes. Hive is a kind of a data warehouse kind of environment, right? Where Hive is a database where you can create a tables, multiple tables, right? And you can perform some kind of querying. And also the advantage of Hive is Hive can integrate with any other external sources, right? Hive can integrate with any, for example, Hive can integrate with NoSQL databases. Generally, one second. So here huge data is there, right? This is HDFS. You got huge data from different sources. You brought this data, right? From different sources, you brought this data. Database one, database two, from database three. In HDF, you are processing. You're processing. If you're processing, right? After processing, you need to take the data back to this database again. Database. After processing, like here I said, like scoop import we use, right? Scoop import. But here like scoop export, right, into database. But this scoop export will fail because here Hadoop, right, huge data, and this huge data, if you want to store within a database, if this a scoop export will fail because of huge storage, right? And after process results, so in that place you can replace this database with NoSQL database like HBase, Cassandra, or MongoDB. In such case, again, if you are using scoop export operation here, right, for exporting data, again this scoop export fail because scoop is only for database and Hadoop, not for this NoSQL or other things, right? So in that case, what you do here, you got this Hive is there, Hive is available, right? Hive can integrate with any of this NoSQL database like HBase or Cassandra or MongoDB. This Hive data can be stored at the Hive data. If Hive data integrated with MongoDB, the Hive backend is MongoDB. If Hive is integrated with Cassandra, Hive backend is Cassandra. And if it is integrated with HBase, in HBase, you can store the data and you can retrieve the data from there. So Hive and the integration is going to work. So in this way, Hive is a component which can integrate with most of the other systems, right? Either Hive can integrate with Spark, Hive can integrate with NoSQL, MongoDB, Cassandra, or Hive. And in the other Hive, you can create many tables, making the data structured and querying on that, right? Fine. Yeah. Yeah. Any other queries, right? Yes. Yes. 1 second. Give me a second. Yes, yes, right. 1 second. So that, as I said, right, both Hadoop and Spark, both we are going to discuss as part of this course, right? I'm sparing like 50 hours for Hadoop and 50 hours for Spark. It's SCALA, right? And the software, don't worry about the software, right? Everything I'll be providing you, and I'll be demonstrating about the software, how to work on it. And the notes, clear notes will be forwarded to you or to your mail IDs. And every session is a video recorded. You will be getting the video record, even if you are absent for a couple of sessions because of some ill health or due to some office timings, other things. You can just follow the video and just can attend the other sessions, right? Course content, everything will be forwarded to you to your mail IDs. Yes. So we have got this DURGASOFT online team, right? Just now you can see they have posted. If you observe that demo link is forwarded, demo link, course content is forwarded, course content and demo videos are forwarded, right? Everything you can see in that chart panel. You can just copy that, right, everyone? And yes, yes, this online team, this they are forwarded. You can just see in the chart panel the entire details, the payment process and procedure, right? So you can just enroll and register with this, right? You'll be getting that material, soft copy, and this videos, like the duration, like 2.5 to 3 months. And once you have done the payment, right, you are supposed to forward the screenshot. You're supposed to forward the screenshot, so the mail ID to this mail ID, right? So DurgaSoft online training, you can just make it DurgaSoft online training @gmail.com, right? So then only they will be forwarding you that links. If in a couple of days, in 1 or 2 days, right, the link is going to be changed only for those who are enrolled, who are registered. They'll be getting the link, right? So sometimes even if you're not forwarding the screenshot, they won't be forwarding the link, right? Okay, please send the screenshot. See there again, we got one more message, right? Right, DurgaSoft online training @gmail.com. Okay, fine. Fine. So I'll stop here and we'll continue the session tomorrow, right? Same time with the same link, right? Fine. So tomorrow, okay. Tomorrow also you can attend the session, right? Tomorrow will be that last, and next in the next class onwards, the link. Tomorrow is the last. and from thereafter the link is going to be changed, right? So those who are enrolled, those who are registered only will be getting the link. So only tomorrow we can just attend the session, same time, same link to see more on this, right? So I'm stopping here for today. Meet you tomorrow, same time, with the same link, right? Fine. Thank you all. Thank you for this time.